that comes over here is what are the plus and negative and positives of this particular algorithm. The first thing that we talk about is a positive. Now, the positive says that no, the link cost, if it reduces, it travels fast. Good news travels fast. That is the strength of it. Now, based on this particular diagram, what you see is that at a particular point of time, the link cost was changed from 4 to 1. So what happens is that at time t is equal to 0, what happens is that y detects that the link cost of this particular structure has changed. So it will inform its neighbor that is said that is there is a change. So what does is it do? It computes that I'll compute this will be a new value. It will compute that it can reach x via y with the cost of 2, and that will update. At time t is equal to 2, or at t2, what happens is that y gets an update from z saying that it has a least cost of sending a data to x, but it is not lower than the cost. I'm sorry, it is not higher. I'm sorry, its current value is lower than what the update it has got from z, so it will maintain its cost. It does not change. So and then it will not give any more updates to z saying that the link cost has changed. So we see that any change in values, the lower side, that means the link cost was 4, it has reduced to 1. It will be updated very quickly, and all its neighbors will be updated, and the algorithm will converge. Now, just like that, the problem with this is that the bad news travels slow. That means instead of saying that no, your link cost it was from 4 to 1. Now you say that your link cost is basically increased from 4 to 60. Now what happens? Now what happens is that no, y knows that no, the link cost of sending your data from y to x is 60. Now it has some information on z saying that no, it can reach this particular fellow via x with this particular value. So what does it do? So x sends its data to z, and z forwards it to x. So what will be the link cost? From z to y to z is 1, and from z to x is 50. Now it has a cost of 51. Now and that it will share. So so what does z do? Z gets that information. So what does z do? Z says that it will forward if it wants to send some information to x, z will forward that to y, and then it will forward that to x. So basically, what does it? Z to x, it says that no, it is 50. So z has to forward it to y, and then from y to z, they say that no, this is the value. No, from y to x, the link cost is what? 51 that you've got. So now what you have is z will be forwarding it to y. So the link cost is 1. And based on the previous value, which says it is 51, it'll be adding it. Now we'll be getting a link cost of sending a data. So this says that this is the cost of sending a data from y to x. This is the cost of sending a data from z to x. Okay, for your information. Now again, the next iteration, what does it do? Y gets a update information. So y knows that it can send the information with the lower value. So y sends it to z, and from z it will go over to x. So z to x, what is your information? Is from the previous cycle, what is being shared? Z to x, the link cost is 52. And you're sending a data from y to z. So 1 plus 52 will be your new cost. That is 53 will be a new cost. This is the new value for y to x. Now z gets an update. So again, it updates. It sends your data to y and y to x. So this particular value for sending a data from z to y is basically 1. And from the previous data from y to x, you said that no, it is 53. So 53, it goes, and your new value will be 54. Now this keeps on updating. Till what time? Till a particular point of time that it exceeds this particular 60. Now, if you once you reach 61, now which is now you say that no, you have a lower cost, that is 60 is there on the other side. So this will be not the path that needs to be taken, and this will be the path. So just to know that there is so basically there is no such path. There is no such path here. So what you call this particular thing is this is basically count to infinity problem. How much times do you need to do? So first iteration got 51, second 52, 53, 54, 55, 56. Likewise, it goes up to 61. Only after that much iterations, it knows that there is no such path. It has to choose this path, and it does. So this is basically count to infinity problem. Why you call it as infinity problem? Now, if it was instead of 60, now just imagine if it was 1000. Now it has to iterate that much number of times till it reaches this value 1000. So that is why you call it as a count to infinity problem. And basically you say that it requires 44 iterations before the algorithm stabilizes. It needs to iterate. This is the most simplest way of saying it. Now, what is the solution that you come across? So count to infinity problem. The solution to that is you call it as Poisson reverse. Now, what happens is that now you say that is that if it wants to send something to X, it goes via this particular route, right? So if Z chooses this route, it says that its other hand. Z has two hands, right? Two links. One link is 1 and the second one is 50. Now what Z says that if it goes via this, it says that its other link is going to what you say, it is going to publicize that its link cost is infinite. Now, the advantage of that is that when this cost has increased from 4 to 60, it cannot say that it has an alternate cost that is 50 to reach X because its alternate cost is infinite. So is infinite smaller or 60 smaller? So 60 is smaller. So it will automatically try to update with the new value. And then we can check if then your normal algorithm flows. So now you might have a new updated structure like Y, X, Z with these values, say 60, 1, and 50. And then your algorithm follows just like what we have studied in the previous session. This is basically count to infinity problem and the solutions to that. So when your question comes as what are the problems associated with that, the advantages is that good news travels fast and the disadvantage is that the bad news travels slow. So you're having the count to infinity problem and the solution to that is the Poisson reverse. And you have some comparisons. You can go to the slides for that. Thank you.